In this video, I'm going to show you how to create your own model and save it so you can share self-check versions, a reference model, or a assessment model with your students. So you're going to hit the Start tool and you're going to go to Create, and I'm going to create a conceptual model, not a stock and flow model, and I hit Create. And this is what you're going to look like. Now, I have already started this. I added a bunch of stuff into the description box for my students. Typically, Biointeractive team has decided on having a background section, an assumptions section, instruction section, and questions. But you can do whatever you want, and here's my title. What I'm using for this is the Biointeractive Inbreeding in Island Wolves data point. So I found this and I want to create a model for this. Specifically, what I'm going to use is this text here along with the data point itself. So I have this information and now I'm going to just build a model. So I'm going to add an object, and due to human activities, many wild habitats are becoming smaller or more fragmented. So part of modeling is trying to choose what you're going to model, and I'm going to say fragmented habitat. And then with that, well, that can lead to a decrease in population sizes. So I'm going to type in wolf population size. So what is the relationship there? As fragmented habitat increases, wolf population size decreases. And the direction of causation is going from fragmented habitat to wolf size population. So it's going to have a negative connector. Next, let's see. And subsequent increases in inbreeding. So I'm going to just put another object in, and I'm going to call this inbreeding. And as wolf population size increases, inbreeding decreases. Small wolf populations leads to more inbreeding, but so there's really an indirect relationship here. The larger the population size, the less the inbreeding. And when you get into these chains of causation like we have here, really have students focus on what are the direct effects and what is the relationship among those direct effects, because we have well-fragmented habitat increases inbreeding. But it's not so simple because we have this object here in the middle. So really what happens is as we have a fragmented habitat, that's going to decrease wolf population, which wolf population size decreases inbreeding. So the more of this, the more inbreeding we have. Okay, so let's keep going. Inbred offspring may have genetic conditions. And as we look at the data point here, what I see here, and I've read this a lot more, it looks like in our Island Royale, which is your kind of experimental group, really what happens is the heterozygotes frequency goes down and the homozygote frequency goes up. So what I'm going to do is I'm just going to include an object and I'm going to call it homozygous genotypes. So what's going on here? As the more inbreeding there is, the more homozygous genotypes there are. Because in the Island Royale is where you're having the small population size, you're going to have more inbreeding as a result of that, and the homozygous frequency is increasing. In the Minnesota population, there's less homozygotes from less inbreeding is the idea. Then that leads to our last object. And let's go back down to that, which leads to inbreeding depression. So I'm just going to call this inbreeding depression. So what is inbreeding depression? That is genetic conditions that reduce their ability to survive and reproduce. So more homozygous genotypes increases inbreeding depression, relates from those recessive alleles, and inbreeding depression, more inbreeding depression you have, the less the population size. It decreases population size. So you kind of get what is really a positive feedback loop. So overall, this is going to be my model. And now I'm going to save. And I'm actually going to save it as a zip file. If you save it here, it's just going to save a reference file, which you can edit to. You can have students build upon this specific model, but I want to have a zip file, which is going to allow me to create a self-check version. So I'm just going to call this inbreeding in island wolves, volume 1. Hit OK. And it's going to create a zip file, so I do have to extract that. I'm going to put in this folder, hit save, there we go. Now once it's saved in there, I'm going to just right click on this, show it in that folder, and I'm going to extract all right into that folder. There we go. So once that is done, see, there we go, you're going to have automatically, let's see if I can make this a little bigger. Yeah, you're going to have 3 files. You're going to have the assessment file, which you'll use the grading tool for, the reference file, that's what the model is checking against, and you can share that file with students if you want them to build upon the model. And then lastly, a self-check file, and that's what we're going to use to share with students. So let me minimize that, and now I'm going to go to Google Classroom. So that's what my students use. I've already created this assignment in Google Classroom, and I give generally these instructions. So I say, all right, you're going to download the model below. Well, I haven't created the model, so I'm going to show you how to do that. I'm just going to go upload and browse. I'm going to go to that folder that I just created. So it's right here. And I'm going to do the self-check. I hit open, and now that's going to be put in there as a file. Now you can't open this file directly, you have to open it through Model Builder. So I say open Model Builder, then open the downloaded model through Model Builder, and that's what you have to do. And build the model until you have 0 mistakes, and then answer the questions. So then I'll assign that to students. From there, let's see what a student would do. So download the model. So go here, and it's going to be gobbledygook for the student. Oops, wrong button. Download. And my students just figured this out fairly quickly. We did this a couple times and walked them through it, and they usually could do it okay. You can just hit save, put in that same folder. Okay, now I'm going to go back to Google Classroom, open Model Builder. And that should just open up right to the app. Now open model. Then let's go, where did I put that file right here. So open it. And there we go. Now it's already in self-check. I'm going to turn the hints off and fragmented habitat. And now students can try to build this model, hit check, see that that's wrong. So we're going to trash that. And as they go through and do this, we can see fragmented habitat. Oh, that's not right either. It's actually a negative connector. So I'm going to check that. Yep, that's right. Wolf population size decreases, inbreeding, and I like to have those arrows, check. So then students can start building these models that you have created all by yourself. And I like to have students check until they get 0 mistakes and then show it to me. And then, oh, that one's not right. Let's try that. Check. 0 mistakes found. And then I always have questions that I like to include for them to answer in the model or in Google Classroom. So I hope you found this model useful.